Today I'm going to teach you about reflections. And what are they? Well, a reflection is just a type of transformation in which a figure flips across the line called the line of reflection. Now basically what it is just a mirror image of the original figure. It does not change its shape. It does not change its size. And this line of reflection can be vertical like you see right here, kind of like your y-axis. Or it can be horizontal, like your x-axis. And your line of reflection can also be diagonal. Now in this video, we're only going to be talking about reflecting across the x-axis and the y-axis, not diagonal. So one way to reflect is just to count your squares, kind of like you did with the translation. This time we're going across the y-axis. So where is the y-axis? That's usually a really important thing to find out. And it's this guy right here. So basically, I need to make sure that my triangle flips over that line. Well, how do I do that? Well, I'm going to count. This letter A is how far from the y-axis? 1, 2, 3, 4, 5, 6, 7, 8, 9 units away. So it's just going to go 9 units the other direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would be where my new A is. The B is 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5. And then finally C is the same distance as the A. So I'll make that a little bit faster. Then the next thing I have to do is connect my points. Now before I connect the points, let me tell you, if you can do this without drawing those lines, that would be fantastic. Okay, there you go. Now, just as a reminder, your original one, which is the pre-image, and your new one, which is the image, are identical. They're facing different directions, but they are the exact same shape and the exact same size. Okay, this time let's go across the x-axis. So where's the x-axis? It's right here. When I do it on a sheet of paper, I actually will go ahead and highlight the axis just to remind me where I'm going. All right, so with that in mind, I'm going to start with the C because it's the closest. And the C is 1, 2, 3 away from the x-axis. So I'm going to go 1, 2, 3 away. There's my new C. A is actually 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7 away right here. And then the B is 1, 2, 3, 4, 5. And so it is 1, 2, 3, 4, 5 away. All right, let's connect those points. There you go. 2 triangles, congruent, and equally distant from the x-axis. Is there an easier way than sitting there and counting the grid? Because I have troubles counting the grid at times. And the answer is yes, but you have to know something about your x and y coordinates. So let's look here and analyze this. The pink triangle is my first set of numbers, and the blue triangle is my second set. And so if you look at the x values, and by the way, we reflect across the x-axis. So I'm going to look at the x values right here, and then I'm going to look at them in the blue triangle. And what do you notice? They're the same. Why did the x coordinates not change? Well, because they're the ones that deal with going left or right. Did the blue triangle go left or right? No, it flipped down. And so that's why my x coordinates are not going to change. Now, what about my y coordinates? What happened with them? Well, 7 became -7, 5 became -5, and 3 became -3. Oh, they just changed to their opposites. Wonder if there's something like that with the y-axis. Well, let's take a look at this one. This is when we reflected across the y-axis. So what happened here? Well, if you look at it, look at the y values. This is your pink triangle, and this is your blue triangle. And what's going on with the y coordinates? They're the same. Why are they the same? Well, because when you flipped over the y-axis, you didn't go any further up or down. You flipped to the right, but you didn't go up or down, so that up or down number is not going to change. Now look at the x numbers. The -9 became a what? A +9. The -5 became a +5. They changed to their opposites. So I bet there's a rule for that. I'm hoping this is not too hard to memorize. When you reflect across the x-axis, your x coordinate stays the same. and the y one changes to its opposite. And when you reflect across the y-axis, the y-coordinate stays the same. So basically, whatever axis it crosses over, that's the coordinate that stays the same. And the other guy changes to his opposite. Let's try some of that. Let's reflect this trapezoid across the x-axis. And so in this case, all the x-coordinates should stay the same and the y should change to their opposite. Now I have a little rule here. It's kind of a shortcut way of saying what I just wrote there. And that just says the x stays as the x, the y changes to its negative? No. In that case, what it means is the y changes to its opposite. So it's not really a negative sign. So let's keep our x's the same, 2, 5, 6, 1, and change everybody else to their opposite. So opposite of 4 is negative 4, opposite of 4 is negative 4. And we have a negative 7 and another negative 7. And then I can start plotting those points. Let's see, 2, negative 4 is here, and 5, negative 4 is here. 6, negative 7 is here, and 1, negative 7 is here. And then I would connect my dots. There you go. I kind of like that, where I don't have to sit there and count the grid. Okay, let's do the opposite. It says reflect across the y-axis. So the y-coordinate stays the same, the x-coordinate changes to its opposite. So here's a shortcut way of saying what I just wrote there. The x is going to change to its opposite, and the y is going to stay the same. So let's do the y first, because that's easy. It's going to stay the same. So that's a 4, a 7, and a 7. And then the x values are going to just change to their opposite. So that'll be a negative 2, negative 5, negative 6, and negative 1. All right, let's go ahead and plot that. So negative 2, 4 is going to be right here. Negative 5, 4 here. Negative 6, 7 is going to be here. And negative 1, 7 is going to be here. And then all I have to do is connect my points. So what do you think? I would love to know which way you like the best. Let's try this with no graph. You ready for this? All right, it's not too hard. Let's start with the first one. It says reflect 3, negative 9 across the x-axis. Oh, the x guy stays the same. So 3, and then the y changes to its opposite. The opposite of negative 9 is positive 9. All right, let's do another one. Reflect negative 4, 1 across the y-axis. Well, what stays the same? The y guy. And so the x1 changes to its opposite. The opposite of negative 4 is positive 4, and then the y guy stays the same. All right, next one. Reflect 5, 0 across the x-axis. What stays the same? The x coordinate. So 5, and then y changes to its opposite? What's the opposite of 0? It's just a 0. Why in the world did that happen? Well, if you think about it, if I have this coordinate plane and you've got a dot here at 5, 0, and you're reflecting across the x-axis, well, it's on the x-axis, so it's just going to stay right there. All right, last one. Reflect the 5, 0 across the y-axis. All right, so the x changes it, and the y stays the same. Okay, let's do 2 more. The first one says reflect 1, 5 across the x-axis and then across the y-axis. Let's kind of talk about what that is. It's going to start here in quadrant 1, and then it's going to go across the x-axis. So it's going to actually end up in quadrant 4, but then it's going to cross the y-axis, and so it's going to be in quadrant 3. And so I'm expecting numbers that are going to be negative. Well, let's see what happens. Across the x-axis means the x guy stays the same. So that's a 1, and the y changes to its opposite. But then when I take that and go across the y-axis, the x guy changes, and the y stays the same. Now, does that make sense? Would you find point -1, -5 in quadrant 3? Yep, absolutely. All right, let's look at the next one. It says reflect -8, 2 across the y-axis and then across the y-axis again. That kind of makes me laugh because I know it's going to happen. Do you? Okay, so across the y-axis means that the x guy changes to its opposite and the y stays the same. And then you go over here across the y-axis, which means the x number changes to its opposite and the y stays the same. And that is the exact same number that we started with. Does that make sense to you? It makes perfect sense to me. Because when we started, negative 8, 2 was in quadrant 2. Then it reflected to quadrant 1 across the y-axis, and then went right back to quadrant 2 when it reflected across the y-axis again. It literally went right back to its original spot. All right, that's it. Taught you about what a reflection is, how to reflect it using a graph, how to do it with ordered pairs. Now it's time for you to go have some fun.